Here I've got a folder of many hundreds of pictures of candlesticks. They come from the Museum of Metropolitan Art in New York City. I thought it would be interesting to compare all of these candlesticks to each other, and the simplest way I thought to compare them would be to simply study the contours, the outlines, the silhouettes of the candlesticks. What I ended up with after analyzing all of these hundreds computationally was a PDF that's very wide, and I'm scrolling through it slowly here, and you can see the contours, just the left side, of all of these different candlesticks. I had a list of every JSON file describing every image in the collection, and I ran this terminal command, fgrep, to find every JSON file that had the word candlestick in it. So then I had a list of all those, and then I simply did a find and replace to make a new document like this, and then I had a list of every image. Once I had the imagefiles.txt document with that list of all the files of interest, I had to copy them off of a hard drive onto my local computer. So I opened it up, read all of the lines in it, and then copied each line, that's the name of the file, from the hard drive into my own computer. Next, I simply wanted to resize all the images in that folder, and so I used this handy little terminal command, sips, with the function capital Z 500 star.jpg when I was in the folder with all the images. That sips is short for the scriptable image processing system, and if you look at the man page, it shows you that what the capital Z function does was resample the image so the height and width aren't greater than specified size. So you can take a huge folder of images, resize them all down to no greater than 500 by 500 in a matter of seconds. Here we see what the processing sketch really looks like. I've got an image of a candle, and I've got a few different lines around it. If I use the up and down keys, I'll move in this bounding box, which I had to set because some images of candles have junk around the edges. And this is the line detector. It is trying to find, that red line is trying to find the left edge of the candle. It's not doing a good job right now. I'm going to turn on mouse control so that moving the mouse will change the value threshold that defines where it thinks the edge of the candle might be. You'll notice if the threshold, which you can see up here in the corner, the threshold's very low, like 0.3 or something, it's definitely not finding the edge of the candle. If the threshold is too high, it probably blows right past the edge and goes maybe to the far edge or something wrong like that. The key is finding the threshold that's somewhere in the middle. In this case, it would be maybe this value, 1.85. In another candle, let's see, this value here, 6.4. In another candle, this value here, 4.5 or so. Too far, and you miss the edge. Too little, and you never see the edge. And the way the software works is it keeps adjusting. It looks through different possible thresholds. This is one, 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 until it sees that red line being least jagged as possible. And then when it sees the least possible jaggedness, it says, aha, that must be the edge of the candle. Now, it doesn't always work so well. This, for instance, is a candle with clear parts because it's made out of glass, and the threshold finder is pretty bad. But in most cases, this method of minimizing the jaggedness of the red line, which then is smoothed out into the green line, finds a decent threshold, and that is how the final output was generated.